Now, in our video on predicates, I noted that it seems a bit artificial and perhaps even just wrong to require that every predicate either applies or doesn't apply to any object under discussion. We saw there the example of the paradox of the heap, but actually it seems as though most of our predicates in day-to-day language work this way. Predicates like old, young, hot, cold, and that kind of thing have border cases that we can certainly disagree about, and we can even talk about things as being hotter or colder or older or younger than other things. And the valuation of just 0 and 1 doesn't really give us a ready way of doing this. This is where fuzzy logics come in. These logics have continuum many truth values. That is to say, they have as many truth values as there are on the real number line between 0 and 1. And they have a ton of applications. Everything from length of washing machine cycles to density of traffic is best discussed in fuzzy terms. Part of what provides motivation for fuzzy logic is the realization that most of the predicates we use in our day-to-day language are vague. For instance, such predicates as tall and short, old and young, hot and cold, and so on. Now, because we have only two truth values in ordinary Boolean logic, which is to say true and false, or sometimes as it's put, 1 and 0, we have to say that for every item in our domain, it's either true or false that it's tall or that it's short, true or false that it's old, and so on. But this seems a little bit strange because we could obviously haggle about whether or not something is tall, even if we agreed that there are definitely tall things, which we both agree on. And we could argue about at what point someone goes from being young to no longer being young. But if we have 1 and 0, we have to have things tip at a definite point. And that's a bit strange and a bit artificial. Fuzzy logic does away with this altogether. So let's take phi and psi to be our sentence variables, and we'll introduce this sign v. So we'll say the valuation of phi is equal to 1 if phi is absolutely true, 0 if phi is absolutely false, but in the middle we can say it's an x which is greater than 0 and less than 1 if it's in between. So if we recall our predicate heap, which we discussed in an earlier video, and we say that A is a heap, well, if we go removing grains bit by bit, it'll go from being an absolute heap, that is to say the value of the claim that phi is a heap, will go from being 1 to being, say, somewhere in the middle. Let's say it's half a heap, or it's half true that it's a heap, to being eventually no longer a heap whatsoever. But now we have at our disposal the whole set of real numbers, so that, for instance, we could say that phi is 0.00125339 a heap or whatever. That's perfectly acceptable because we don't want to have any jumps, and so we need there to be continuum many truth values, that is to say, as many as there are real numbers. That's the basic idea of fuzzy truth values. But there is a problem still. Take our real number line and talk about moving our heap in truth value by removing grains from 1, definitely a heap, down to 0. So we go removing grains of sand from our heap, so it goes from being definitely a heap to mostly a heap, and then at some point it goes to being mostly not a heap to definitely not a heap. And the question is, how do we pick these points here? How do we decide where it goes from being absolutely a heap to mostly a heap, from mostly a heap to mostly not a heap, and from mostly not a heap to absolutely not a heap? And so there's a problem here in determining still where it goes from being a heap to not being a heap. Now this is a twofold problem. On one hand, it's an epistemic problem. When can we know that it's no longer a heap? And on the other hand, it's a metaphysical problem. When is it just true, no matter what, that this pile of sand is no longer a heap? Now, the epistemic problem doesn't usually trouble people as much, but the metaphysical one does, because it seems that we'll have to posit that maybe we don't know it, but at some point, our pile of grains of sand goes from being a heap to no longer being a heap. So there remains this very deep problem in terms of our analysis of how vagueness works in natural language, and fuzzy logic, while it's a very powerful tool, still presents us with some serious problems.